What's up, guys? We should be doing a nice little 6-1 here about inverses, and we started the lesson off with Desmos. So your teacher should have emailed you the code for you to get in for Desmos. Go to student.desmos.com, and here's what we'll do. It's kind of doing in little chunks. Once you log into Desmos, do slides 1 through 4, and then just kind of stop there and come back to this video, and I'll give you more instructions. Then we'll do slides 5 through 10, and then we'll come back to the video. So when you log into Desmos, just go 1 through 4. Alright, so here's slide 1. You'll have to do a little reading. Remember we talked about inverses last time. You switched X and Y around. That's a major thing. So go to Desmos right now, do slides 1 through 4. Okay, so on the second one, a relation is a set of ordered pairs. That's what we should have there. Inverse, notice how they just switched X and Y around. That's what an inverse is, switching X and Y around. So this should be 3, 6, 6, 8, and -4, -3. So now on slide 5, in class it was a little tough because students have a hard time understanding what they're supposed to do here. They want us to graph the inverse of f of x. Hey, look at this. It will literally tell you what to type in line 3. We don't have to do any work at all to graph the inverse on Desmos. Desmos is really cool. They say type x equals f of y in here. So that's all you type. X equals f of y. And look at this cool thing. The inverse shows up in that case because x and y switched places. And what the next few questions are going to ask you is to see how this new line, the green dude, relates to the original guy in comparison to this line y equals x. So do slides 5 through 10 and then come on back to the video. So 5 through 10. Go ahead and pause and do those now. Okay, so after you've done 5 through 10, just kind of show you what's going on here, because it is confusing, you know, but check out the next question says, what do you notice about your green line compared to this red line? Well, look at what all these black points would be if we just reflected them over this line y equals x. Wouldn't they like totally land on the green line? So these guys reflect to each other over the line y equals x. And if you see this, the same thing happens. They started with this horizontal line here in red. When we graphed the inverse, it became a vertical line because we let y equal x. They reflected to each other over the line y equals x. So that's the same answer here. I know you might not have got that. You know, that's okay. Just keep what you put. You know, you don't have to change it. But still, you'll see that here also, that this green parabola totally reflects to this dude over the line y equals x. Like if I was to have this as a piece of paper and fold it on this line, the red one and the green one lie right on top of each other. So that's why this answer is they reflect to each other over the line y equals x. So that is the moral of inverses in this case. So inverses reflect to each other over the line y equals x. Now there's still some more Desmos slides to do, but we're going to go back to our practice sheet now. So before we can finish the Desmos, we got to go do some work here. The ACT and all these cool test questions that are coming up are going to ask you some simple questions about the graphs of inverses. So this is tough to see because it's so small, but here's like the original graph right here. It's some sort of parabola. And they want to know on this multiple choice question, like, which one of these 4 graphs is the graph of the inverse? Well, remember that inverses reflect to each other over the line y equals x. This is the line y equals x. So there's 2 ways to kind of see it. Number 1, on these guys, they give you like an ordered pair right here. Like the vertex of this guy is at -4, -3. And since we want the inverse over here, remember, doesn't that mean x and y switch places? So I got to look over here to see which one of these dudes has the vertex at switch -4, -3. And yes, it's hard to see, but this is at 4, -3, so he's out. This guy is at -3, -4, so he's out. And this guy is at 3, -4, so he's out in this case. I need -4, -3 in this case. So this is the right answer. You can also tell because this guy reflects to the dude over the line y equals x, because if I reflect this, you get that cool sideways parabola thing looking here. So that's a neat little question there. Okay, and now before we can still go back to Desmos, today's lesson is really about to tell if the inverse of a function is a function. So old school, we've done this a long, long time ago, but these graphs down here, they are functions because they pass the vertical line test, right? You don't have to draw any of this, but if I draw a vertical line through this graph right here, if it touches it in one place, that's okay. But if it touches it in more than one, that's not good. Like every element of the domain does not map to every element in the range. So that would not be a function. But this is one place, one place, one place. I could do this all day. This dude passes the vertical line test. And so does this guy over here, right? That's not what we're talking about today. These are already functions. They want to know if the inverse is a function. So, since we do the vertical line test to tell you if you're a function, the inverse of that, well, what's the inverse of a vertical line? It is a horizontal line in that case. So what we do is we do the horizontal line test in this case. So they want to know if this guy's inverse is a function. So if we do the horizontal line test, if you touch in one place, that's okay. If you touch in more than one place, that's not okay. So you got to just kind of test some out. You can draw them if you want to. You don't have to. So far, so good. The weird part is this little inflection point here, the little twisting zone. And I'll tell you, with just our math experience, you can draw a horizontal line in there all you want. It's still only going to touch in one place. So the answer to this is the inverse of function is yes. And the reason why is, here's what we'll say. The graph, don't say it, the graph passes the horizontal line test, which we can abbreviate HLT. So the vertical line test tells if the original dude's a function. We want to know if his inverse is a function. So we don't even have to graph it or do any of that cool stuff. We just do the horizontal line test. So on this dude, they want to know, is the inverse of this guy a function? Well, that's a big fat no. Would you believe that this horizontal line intersects the graph in more than one place? So we will say no. The graph, don't say it, we'll say the graph failed the horizontal line test, which you can definitely abbreviate HLT. So there's two warm-ups. Let's go back to Desmos, and there's just 4 more simple problems right here. They want to know if the inverse is a function or not in this case. So go back there, finish that real quick, and then come on back to the video. Alright, so we finished the activity. That's good. And now your teacher will end up grading that. So good. Just make sure you've answered them all. And let's go to the back side of the worksheet and do these problems. Real simple day, right? A little shorty. So they say graph a sketch of the given problem to answer these questions. Cool. We got to graph this guy. Let's make it easy on our brains. Yes, we could use a graphing calculator, but we got that ACT coming up, and we want to do things as fast as possible. So my basic question in my class was, hey man, is this going to be like a line? Is it going to be like a parabola, or is it going to be like a cubic dude, you know? And it's like they all said line. This is a line, which I agree. This is a line. It's got a y-intercept of -5 and a slope of 2. So we could just make a rough sketch of that real easy. Y-intercept of -5, probably like right here. Slope of 2, that's positive. So it's like going up from left to right. I kind of missed my point there, but it's going up from left to right. This is a perfect sketch of the line 2x minus 5. Y equals 2x minus 5. So we make a sketch of this dude. If you didn't know what he looked like, you could punch him in the calculator. They want to know if the inverse is a function. Well, that's where we use the horizontal line test. And this guy, he would pass it. So yes. Why? The graph passes the horizontal line test. Simple enough. So that's part A. They wanted to know, is the inverse a function? Explain. Then if you say yes to part A, which we did, right, then we got to answer all these other questions. So part B says, find the domain and range of the given graph. So, okay, domain goes from left to right. And would you believe that this dude, it goes from -infinity to +infinity? And the range, if we go low to high, if you put like a straight edge down here, this thing would run into it down at -infinity, and we go all the way up, it'd be the +infinity. Today's a real easy day where the domain and range is pretty simple to find. So they wanted to know the domain and range of the original. Part C says find the equation of the inverse using the 4-step process. So that's what we did on Desmos last time. We got to do the 4 steps. So the first step was to change f of x to a y. Simple enough. The second step is the true inverse step. That's where you switch x and y around. That's what inverses are all about. You switch x and y around in that case. So did it. And then step 3, we're going to solve for y in this case. So first move is to add 5 to both sides. And then divide by 2. It's okay, depending on what your teacher says, if you put it all over 2, you could do x plus 5 all over 2, or you could do x over 2 plus 5 over 2. Either one of those. You could divide every nugget by 2 or just the whole thing, whatever they want. Either is what I'll accept. But we got to do step 4. Step 4 is to write the equation of the inverse. So we change y to f inverse of x. Don't call it f to the minus 1, call it f inverse of x. So I'm going to do that as x plus 5 all over 2. And that goes in part C. So nice. And then, again, this is a pretty easy day, like we're just easing into this, but there's a trick to finding the domain and range of the inverse function. Like to find the domain and range of the inverse function, we don't need to see a graph of it. We don't even need the equation of it. All we need to know is the domain and range of the original dude. Because if this is the original guy's domain and range, and since inverse means we're switching x and y around, all we have to do to find the domain and range of the inverse is switch these around. The range of the original guy is now your domain of your inverse, and the domain of this guy is the range of him. And since they're both the same thing, that's kind of a piece of cake. As we go through the chapter, they will be different, so you just pull the old switcheroonie. That's what an inverse is. You're just switching stuff around. So switch x and y around, switch domain and range around. Let's go to the next one. First thing, to find out if the inverse is a function, we do want to graph this guy. And I don't know what he's supposed to look like without punching him in my calculator, so we'll go to the calculator and punch him in. So if you got your graphing calculator, make sure you type him in right. Looks like so. Make him nice and large and in charge for you guys. Well, maybe. There, it's all large and in charge. So I'll zoom 6 it to graph it on the standard window. And it looks something like this. So I just need to go make a sketch of that guy. So it doesn't need to be perfect, just a basic sketch. He did a little dip-de-dip right here. Looks something like this. So let the calculator help me there. They want to know if the inverse is a function. Well, we use the horizontal line test to tell that. And if you had this horizontal line right here, no way would it work. So this is a big fat no. Explain. The graph failed the horizontal line test. So always talking about the graph though, don't say it. So the graph failed the horizontal line test. Then if you say yes to part A, you do all this other stuff, dude. We say no, so it's not happening, right? This, we're done. That's nice. So we'll do the next guy. If you want to punch this in your calculator to see what it looks like as a graph, you totally can. You just need to know that when you're punching in a numerator or a denominator that's got more than one term in it, you need to put it in parentheses. So you can punch that in if you want to, or if you know that that's basically the same thing as this, this is like x over 5 minus 3 over 5. It's kind of why I like to go both ways. This is in slope-intercept form now. This is a line. It's got a y-intercept of -3/5, and it's got a slope of 1/5. So it like rises 1, runs 5 in that case. So he's a line in that case. Either way, just as long as you type it in right or you know what it looks like. You want to know if the inverse is a function? Well, that's a big juicy yes, because the graph passes the horizontal line test. And then we get to do these next questions. So part B was find the domain and range of this dude. Well, it's a line. It's an oblique line. The domain will always be all reals. And the range, going from low to high, also all reals. Part C was write the equation of this guy inverse. So we'll do the 4-step process. I do like this version better with the all over 5 to do that. So step 1, change f of x to y. Step 2 is the true inverse step. That's where you switch x and y around. Doing a little reverse. Step 3, solve for y. So we'll do that. So that would be, when you have an all over like this, you can get rid of that first. So that'd be 5x equals y minus 3, and then you just add 3 over 5x plus 3 equals y. And don't forget step 4 is switch y to f inverse of x. So nice. F inverse of x equals this. Domain and range, we pull the switcheroony on the OG's domain and range. Don't make it any more complicated than you have. What you got from part B, just pull the switch. And it's weird because they were both all reals. Like I said, later this chapter, it won't be that way. There'll be different things because we'll do more complicated functions. Hey man, last one. We got ourselves a cube root. So let's see what this graph looks like first. So we'll go punch this dude in. Let me get rid of this. To type a cube root in, remember we can just raise it to the 1/3 power. So we'll do x to the, let me make it large again so y'all can see what I'm doing. If your calculator has a little superscript thing, you really don't need to put the 1/3 in parentheses. But if you have a caret here, you know that little arrow thing you do, I say this, just put the dang fraction in parentheses anyway, right? That way you're always good. So x to the 1/3, that's the way we could cube root it, and I believe it was plus 2. So I'll hit graph on that guy to see what he looks like. It's like a little sideways snake right there. So we'll make a sketch of him, like a little sideways snake. Doesn't have to be the most beautiful thing in the world. And we'll see if he passes the horizontal line test. He is a rare graph. We haven't seen much of that before, but what you need to know about this graph is it will keep getting higher and higher and higher as we go to the right, and it will keep getting lower and lower and lower and lower. So just some experience there. So he does pass the horizontal line test, baby. So the graph passes HLT. The domain and range, it will go as far left as humanly possible, so that's negative infinity to positive infinity. And as I work my way to the right, it does keep going. So then, sorry, I got ahead of myself. The range, as low as we go, remember this will keep getting lower and lower and lower and lower and lower, so it will go down to negative infinity, and this thing will get higher and higher and higher, so it will go to positive infinity. Sorry, I got a little ahead of myself there. Step 3, let's write the equation of the inverse. So switch this to a y, meow, 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 and then switch x and y around. So that would be x equals the cube root of y plus 2. And then for the tricky parts, right? So it is a little tricky. Remember, when you're trying to solve for y, you want to get that term all by himself, right? So it's this term needs to get all by himself first. So we'll get rid of the plus 2 with a good old minus 2. So I got x minus 2 equals the cube root of y. And watching you guys do the Desmos last time, I watched a lot of good things, like we were doing things well. To get rid of this cube root, remember you want to cube both sides. So it's like this whole side gets cubed, and this whole side gets cubed. And the cube and the cube root cancel each other out, so you're left with a y, and just leave it like this x minus 2 quantity cubed. Because it's a binomial, you can't just cube the x and cube the minus 2 and call that x cubed minus 8. You got to take x minus 2 times x minus 2 times x minus 2. It's this whole quantity that you've got to multiply out. So no. Let's not multiply it out. Let's just rock with this. So, alright, so we get f inverse, that was step 3, meow meow. Step 4, f inverse of x equals the quantity of x minus 2 cubed. So f inverse of x equals the quantity of x minus 2 cubed. And then pull the switch. So easy stuff. I do want to show you something on your homework though. There's a problem that we didn't quite actually end up doing. So if you grab the homework sheet that your teacher gave you, let's check that out here real quick. Alright, so this is the homework. If we scroll on over to the 3rd page, number 9 and 10, just want to kind of help you out with that. So they say graph the inverse on the grid provided for you, right? So they give you the original, they want you to graph the inverse. If you know what an inverse is, it's a simple game because you're just switching x and y around. So on this line right here, they give you all these ordered pairs, switch x and y around, plot those new points, and take a straight edge and connect them together. But over here on 10, it's more challenging because it's not a line. It's all curvy McCurverton. So here's what I told my kids to do. Here's what I told my kids to do. Let's label these points right here. I know it. Hold on. Okay, let's label these points is what I was trying to say. A, B, C, D, E, and F. Right? Then you can do the old switch-a-maroony to plot the points for your inverse, but call it like a to the -1, b to the -1, like the inverse of it, and then you'll know how to connect those dots together because they'll connect from A, B, C, D, E, F all the way through. So, all right, man, let us know if you have any questions. Have a good one.